Alright, time for another teardown of something that I've been neglecting. Pardon me as I adjust brightness just a little bit here. There we go. So I got sent these little power banks here a while back, but in addition to being a standard power bank, so I can just plug this in and, but there we go. It turns a little light on if I touch it, so, it acts as a standard power bank. But one of the other features it has is if I press and hold the power button here, there we go, you'll notice that little red light starts blinking slowly. And if I press it again, the little red light starts blinking faster. Oh, and then it just lost power. That was kind of cool. And then, of course, if you press and hold the button again, it will shut down. So what this is it's actually a pocket warmer. And I'm going to take one of these apart. I currently have one of the pocket warmers, because I have two of them, in its little sleeve. It comes with a little knit sleeve here. Sorry about the distortion here, that's just a side effect of the polarizing lens and an LCD. But there's not much I can do about that. So right now it's saying about 45, 46 degrees Celsius. That's set to its higher temperature. So it actually gets pretty toasty when it's running. And I've had this running for about 10 minutes, so it's had enough time for the temperature to stabilize. So I'm just going to click this once to set it to its lower temperature setting, and we'll see where that goes while we're dismantling this one. Now I'm going to make a quick prediction. Based on the shape, I'm thinking we're going to have a kind of a thinnish, probably reasonably anemic lithium-ion flat cell, not one like an 18650. We aren't going to have a round one, we're just going to have one of those flat pack cells. Sort of like a larger version of, do I have the thing anywhere nearby? No, it's probably out in the kitchen for some reason. Yeah, I don't have an example close to hand, but the little flat foil-wrapped lithium-ion cells. So we're going to have one of those. I think we're going to have one and maybe two of those graphite-infused fiber panel things that are used for heating. Probably not going to have any sort of thermocouple or anything for regulation. It's probably just I'm assuming it's pulse width modulation or even maybe just resistor controlled with a transistor that's going to regulate the current going to the panels, and then we'll just have your standard lithium-ion charge circuitry. The batteries are probably connected directly to the heating panels via a transistor, I'm thinking. Anyway, let's see if my predictions are correct and open this thing up. Need a smaller screwdriver first, so let's go ahead and get a smaller Phillips here. See if we can open this up. Yeah, there we go. Tiny, tiny, tiny little screw on the bottom here. And then one more little tiny screw. There we go. And then I think that'll come off, yep. And this should just kind of push out like a little drawer. Yes, there it goes. Ooh, okay. Huh, I'm already surprised. Alright, so let's set that aside there, we'll put that aside too, and let's start having a look at what we've got going on here. Oh, I'm actually kind of impressed so far. Alright, so what I'm looking at here is it's actually got a pretty beefy cell in here. I'm really surprised at that. I'm trying to carefully peel off this other thing that I'm also surprised about without annihilating anything, because I'd like to put it back together. This is actually a lot higher quality than I thought. Yeah, I'm not going to be able to peel that up without causing damage, but you should be able to see. Let's go ahead and zoom down. You can see in there that it's actually got a pretty sizable lithium ion pack there. And this is what's really blowing me away. It's actually got a proper nichrome or canthal or something heating element here. It's not the resistive fiber stuff, which is what I thought was going to happen. And it's got a fluffy insulated something or other here to keep it from overheating the battery, although I'm not entirely sanguine about the positioning of the heating pad directly on the battery there. But at least they insulated a little bit, and there's two of them. And on this one, I'm not too sure how well it's going to show, but you can see just right back in here, there is actually a thermocouple in there. These little red wires coming out of it there. So it is temperature regulated. So I'm very, very surprised about that. Let's go ahead and see if we can pull the circuit board out here and have a quick look at what we've got going. I'm probably not going to be able to tell you too much about the operation of this. It's going to be a microcontroller of some sort that's handling the function, the heating function, but we can still have a bit of a look-see, assuming I can even get the circuit board out here. So let's see what we can do. I may not be... Oh, there we go. Yeah, this nice silicone wires leading up to the power, or leading up to the heating here. But I'm not going to be able to pull this out very far because they've got it soldered basically directly to the cell there. So let me see what I can identify here. We have a blank, let's see, 1, 2, 3, 4, 5, 6, 7, blank 14-pin chip here. That's clearly a microcontroller of some sort. We've got a transistor here that's switching power to the heaters on the front and back. We've got two different ones there. Wow, there's actually a lot going on here. We've got a bunch of different control circuitry. These look like, yeah, these are dual MOSFET packages here, so they've actually got a very robust charge protection for the lithium cell there, which is exceedingly surprising considering these were super crazy cheap. This is the chip that's controlling the boost circuit. It's connected to this inductor here, so that's going to be the buck regulator and the boost converter for charging the lithium cell. I'm assuming it's a buck regulator. It may just take advantage of this chip here, which I can't remember the designation of that, but that you see one of these in every single lithium battery pack in existence. It basically just says, okay, it's at 4.2 volts, we're going to cut it off. Oh, it's at 3-something volts, okay, we're going to cut it off. And uses the MOSFET packages to accomplish that. We got the little button to turn it on and off. And yeah, that's actually a surprisingly robust and well-built little thing. I just accidentally turned it on, apparently. How did I manage that? Probably accidentally shorted something on the circuit board there. But yeah, that's I'm well impressed with that, because it's got the actual nichrome or whatever heating elements. It's got two of them. It's temperature controlled, so it doesn't run away thermally. It doesn't seem like there's an appreciable difference between the high and low setting, because that's only at 43 degrees. It was at 46 earlier. Yeah, I don't have much else to say about that. I really can't, because this microcontroller, it doesn't have any numbers on it at all, but that's going to contain the code that, does what it's supposed to do when you push the buttons and turn it on and off. It's probably got something to shut off the heater if you plug in, a load on the USB output. But yeah, that's pretty cool. That's a lot better built than I was expecting. It's got safety features, it's got proper heating elements. Not entirely too sanguine about the heating element being directly pasted onto the lithium cell, but I'm also astonished at how big the cell in this actually is. So, yeah, not bad. So there's one of the remaining teardowns that I've been meaning to do and haven't gotten around to doing yet. So if you haven't already, consider clicking here to subscribe. Right over here is a video that YouTube thinks you'll find interesting based on your watch habits. Right over here will be the Teardowns playlist, and right here will be a link to Patreon that you can use to help me obtain more surprising stuff like this. Anyway, thanks so much for watching. See you next time.